to Women Techmakers panel, Experiences Developing on Android Things. My name is Melissa. I'm a program manager here at Google, and I work on the Android Things team. And so in a moment, I'm going to let the wonderful and amazing women to my side introduce themselves, and we're going to talk about how they're all Googlers and how they all work together on a series of projects actually based on Android Things. So over the next 40 minutes, we'll actually walk you through their prototype to production story, what they learned, what they loved, and of course, what they loathed along the way. So let's meet our lovely ladies. Let's start with Rachel.
Sure. Hi, I'm Rachel Petterson, and I am a software engineer at Google, obviously.
Do you want to? I'm going to interrupt you. Let's do this true Google fashion. So why don't you tell us how long you've been here, and also a fun fact too.
Sure. And I can tell you what I work on also. So I have been at Google for 10 years. I work on Google Cloud Search, which is our enterprise search solution. And a fun fact is that before coming to Google, I used to work on visual effects for movies, and I've got a credit in Transformers.
Nice.
I'm Carson Holgate. I am the tech lead on one of Google's internal communication tools. I've been at Google for 5 years, and a fun fact about myself is that I wrote the software for a bartending robot.
Yeah.
Yeah, that's really cool. I'm Vaas Krishnamurthy. I'm an embedded software engineer at Nest. I've been there 5 years. And fun fact about me, I've been part of this dance group called Bay Area Flash Mob. We have danced at hundreds of places, and in the San Francisco, from Pier 39 to Union Square to even the mayor's ballroom in the city hall, by just mingling with the crowd and then just breaking out into a dance.
Did you intentionally dance in the mayor's ballroom, or did you not know that you were going to do it?
No, we intentionally. It was for a wedding that was happening.
Oh my gosh.
So yeah.
Nice.
That's awesome. And then my name is Brittany Wilbert. I am a privacy engineer here at Google. And one fun fact about myself is that I'm a builder and a tinkerer. And most recently, I built 3D printers.
Awesome. So thanks for introducing. So you guys will all hear a little bit about everything that they've done along the way and how they used Android Things. And so for those of you who aren't familiar, all of these projects were built for something called Grace Hopper. So Grace Hopper is the world's largest gathering of women technologists every year. And each year, Googlers participate. And this past year, my team, Android Things, partnered with the Women Techmakers team, which is a global program for women in technology. And so Google's Women Techmaker team actually helps to work to provide visibility, community, and resources for women in technology to drive innovation and participation in the field. So they do this through things like hosting events, launching resources, piloting new initiatives and organizations, and obviously teaming up with fun teams like mine. I mean, I'm a little biased because it is my team. But to make sure that women all over the world are supported in their industry. So naturally, when the opportunity came up for us to work with the Women Techmakers team and then find a whole bunch of amazing volunteers across Google to build things, we jumped at the chance. So how did you guys get involved? So I know, obviously, how I got involved because I got excited and was involved with the Women Techmaker group. But how'd you guys get involved?
Sure, I'll take that one. So around sometime July, so Grace Hopper is in October, around July, Melissa sent out an email basically asking for volunteers to work on something for Google involving Android Things. I personally had been involved with Grace Hopper at Google for many years, and so this sounded like something different and interesting, so I was really excited about that. And plus, I had really been wanting to get involved in Internet of Things, and this seemed like a great way to blend those two interests.
And I was trying to get tickets to Grace Hopper, but I couldn't.
It was your free pass.
Yes, you were the free pass. Also the free pass to I.O.
Don't tell.
So I wanted to get involved with Grace Hopper, and I saw this email come from Melissa about Android Things, and I have some Android experience and some hobby hardware experience, so I figured I'd be able to contribute.
And I saw Melissa's email, and I'd heard about Android Things, never used it, so I thought this is my chance to use it. And also, this was my chance to meet other great women at Google, which I did, and so I signed up.
And for me, I was actually a noodler, a new Googler at the time. So I wanted to find something that would be interesting, where I can meet new fellow Googlers at the company and just learn more. So fortunately, this came in my mailbox, and I was able to take a part of it.
And none of you guys really knew each other before this, right? So this was, you guys kind of knew each other.
Yeah.
Yeah.
Okay.
Not as well as we do now, though.
Yeah, that's true.
Now you tolerate each other. Okay. So, and from that, you guys just instantly knew what you wanted to build, right? So you saw the email from me, and you're like, Grace Hopper, Android Things, got it, I'm gonna do this, I know exactly what's gonna happen, right?
Yeah.
Oh, okay. I feel like you're lying to me. So actually, can we go through what that process was like? Like, how did you come up with or ideate and go through things? And what did you build?
Yeah, so for Steve, so I'll talk about what we did build. We built Steve the tree, which Steve is a giant 20-foot by 20-foot footprint and 17-foot tall tree. So takes up a lot of space there. Steve is a Joshua tree. That's what he was based on. And we built everything in Steve. So the tree itself, it's got rebar, core, foam, completely flame retardant, fire marshal, it's all good with that. And then he's covered in about 5,000 LEDs and 20 some odd sensors, including force resistive sensors, microphones, light sensors, gesture sensors, so that attendees to the event could interact with Steve and wave to him, and he reacts through his LEDs, through the frequency and the color and how many that are showing. But Carson, you want to talk about what he started as?
Sure. We didn't start with the idea of Steve the tree. Steve was originally supposed to be a smaller part of like a larger open world interact with the things kind of game, and it all converged into Steve, and we incorporated a lot of the ideas for the different kind of sensors and the light show into the main tree.
So you keep calling him Steve. Why? Where did the name Steve come from?
So all of my things are named Steve. The bartending robot is named Steve. My Roomba is named Steve.
Is there a real Steve?
There is a real Steve. Steve is a friend of mine who works at Verily. He's the nicest guy you will ever meet.
Is he also a bartender or a tree in his free time or anything?
Yeah.
Okay. Good to know. So based off of this, it sounds like you were building with tons of sensors. And what does this look like? So what were you guys doing here?
Right. So we were working with a bunch of different sensors, and prior to this, I hadn't worked with Android things, and I hadn't really done much with hardware. So this, actually, the slide that you're seeing here is me connecting four different force-resistive sensors using an analog to digital converter. There are easier ways to do this that I now know, but there was a lot of learning that took place in building Steve. So.
And then these are all the lights that you're talking about.
Yeah, this was the demo that we did in the local Google Makerspace. Laid out all 16 strands of 5-meter LEDs and wrote different values so we could show the light show and make sure it all worked.
So is Steve here at I/O? Can we find him?
Steve would have loved to make it. We would have loved to have him here, but he put down roots in Houston.
And this is basically, so you mentioned he was built with rebar and all this stuff, so this is basically the construction. He's pretty big. I mean, that's pretty impressive and massive, right? So, I mean, I've never built a 20-foot tree, so I don't know about you guys. So, what about you two? So tell us what you guys built.
Yeah. We built Rosie the android. She is a walking and talking android. So she is controllable using a phone app, using a nearby connection. And on the top, she has a camera that can capture a picture, and it can do some image processing, and it can detect facial expressions, and it can detect accessories and speak to the audience. She can also tell them, hey, nice hat, I like your smile, nice to meet you. So she would raise her right arm and offer a handshake.
So how big was she?
She was huge.
Yeah, so the first version of Rosie was about 4 feet tall, including the rubberized wheels that were at the bottom. She was actually made out of, the first version, out of styrofoam, wood pallets, and a trash can. So we initially wanted to use other methods, but this was the solution that we can make in such a short amount of time.
And so I heard there's a rumor that Rosie is here on site today. Is that correct? Is this the same version that you guys built, or is this a different version? Or what did that process look like from going from a base like this? I believe that's a trash can lid,
yeah,
right?
that's just the lid of the trash can, yes.
Okay. So how did you go from a trash can lid to, I believe there's a giant robot outside.
Yeah, oh yeah.
Yeah, it was a lot of work. So the initial version of Rosie was going to be something similar, or maybe not as similar as what was happening today, but we went going to hardware design. But today, it has evolved to a 5-foot tall Android that can roam around, that uses machine learning techniques, as well as the implementation that Vaas worked on as well. So it's really awesome.
So it's really like the prototype. You guys truly went through and prototyped her and had your initial concept version of Rosie, and then took your iteration of her, and then ended up with sort of a production version that we see out in the world right now, right?
Yeah,
and all built in Android things.
Yes.
Yes.
It's pretty cool. I mean, I interacted with her. She's pretty awesome.
Yeah.
So, okay. So it looks like you guys.
Yeah, that's us at
I went too
a
fast.
hardware store, buying the trash can, and yeah.
So was that always the plan to build her? You mentioned that you had to ship the plans and stuff like that. So
Yes.
What was your initial plan? If it wasn't to use a trash can and to use foam, how did your design and your evolution change?
So the first version of Rosie was actually created using a CAD file. So I took about 2 weeks to create the CAD file, and then we went around to different shops to ask them, hey, can you fabricate a 5-foot-tall Android in about a week or so? And unfortunately, they said no. And one of our fabrication labs that is here at Google, they said that it was too big for the specifications that we provided. So, basically with a week and a half left, we decided we still want to do this. So we went to the hardware store, and we went to fabric stores and got a cake box and other sort of supplies.
Yeah, Brittany was really creative. She got a styrofoam cake box cover for the head. We used PVC pipes for the arms, and we used this giant trash can for the body. It was quite a lot of work.
Definitely an iterative process, right?
Yes, definitely.
It's amazing. And so it looks like, so we know how Steve got his name. So why Rosie? Where'd that come from?
It's from Rosie the Riveter. So the World War II era individual who inspired a lot of women to decide to go out into the working place. So we wanted to have something that a lot of visitors of Grace Hopper would be interested in understanding and have a good experience with.
Yes, it's pretty cool. And I understand that's part of what's built into her ML tech right now, right?
Yeah.
So you can flex just like
Yeah.
that's my poor flexing. I don't know how to flex apparently. Just like Rosie, and then it'll trigger her ML. That's pretty cool. So getting back to all the tech, you guys have all kind of touched a little bit on this, but all these demos are built using Android things. So before you started working on Android things, did you guys have any hardware experience? Rachel, you said no, or a little bit.
Mostly putting some LEDs, but not really with microcontrollers. So.
Brittany, you built a 3D printer.
Yes.
But then Vaas and Carson?
I have half an electrical engineering degree, and I've done some hobby hardware in the past. So, but
Just
nothing.
half a degree.
Half a degree, yeah. But nothing of the scale of Steve the Tree.
Yeah, I've had hardware experience, but I've never built anything from scratch or to the scale.
And you guys have never used Android things before?
No, not at all.
Well, not bad, right? So because you hadn't used Android things before, how did you actually validate your software and through the development cycle? So deciding that, to make Rosie's arm move or Steve's lights and all the sensors and stuff. So what did that process kind of look like? Did you know it worked?
Yeah, so in the case of Steve's, each of the sensors connects to an Android Things card, and the LED strips also connect to cards. But what we did was we had each of the cards would write to a Firebase database. So they would write the raw values there. And part of the reason we did that was because we didn't know exactly what the situation was going to be when we got to the Women Techmakers event. So for example, the force sensors, we knew that those were going to have grass over the top of them, and we didn't know how much that would affect the resistance. And for the sound, we had no idea how loud if people were going to be shouting at him, or if there was going to be background music. So we accounted for that by having everything right to the database, so we could then modulate those values once we got there.
Yeah, so the sensors would write to the Firebase database, and then we had cloud functions that would translate those raw values into an aggregate that the individual strands of LEDs would read from and use to determine how fast they're going and what color spectrums to run through. That way, during the event, if it got louder or something happened with the force sensors on the floor, we could change the code on the fly on the server and not have to go around to every board and reflash them.
Great.
And for Rosie, I started just by downloading Android Studio, trying out a sample app, and then I started looking on GitHub for samples that I could potentially use on Rosie. And I found this perfect one for the movement of the robot, which was, it's called the robot car. It's on GitHub. If you look for it, you'll find it. So this, basically, it gives you instructions on how to compile, how to load the app, and build this small race car kit. So I started with just building this run-trover race car kit. And while debugging it, Android Studio was great because once you plug in your phone and your IMX70, the development board, you can see in 2 parallel tabs, you can see the logs. So you can debug the connection that way. So once I got the small robot car working, I scaled up to much bigger wheels and much bigger, higher torque motors that we needed to carry the weight of the robot. And similarly, for the portion with the image recognition, we did the same thing. I looked for things that I could use with the kit. The kit comes with an LCD screen and a camera module. So I went to GitHub and looked for a sample that would let me use all this. And again, I found this smile detector sample that was out there. And that was great. And I replicated the same thing and pulled it in and changed a bunch of things to get it working on a Rosie. And for the arm movement as well, there is a simple PWM sample. That's in Android Things. And yeah, put all these different pieces together. There were obviously a lot of challenges for all of them to work together. For example, now when I scaled up to this bigger motors, higher torque motors, now they needed a much more bigger battery. And then that was operating on a different voltage. It was operating on a much higher current. So I had to buy a huge LiPo battery. But then this board was still powered off of a 5-volt supply. So a lot of learning there. Definitely a bunch of burned motors in the course.
Just a couple, right?
Yeah. In the end, everything kind of came together.
Yep. And Vaas did all the hard part. I just didn't.
No, I don't think so. Couldn't have done it
that's
without.
not even close to true.
No, no way.
Very shared distribution. So when you guys all started at Google, did you ever think that part of your job would actually entail building like giant robots and giant trees? Is that part of the Google?
Yeah, that's like standard
recruitment
Google
mantra?
software engineer. Yeah.
No.
I don't remember saying that. Right?
Not at all.
Yeah, I missed that part of orientation.
You must have been in orientation.
Yeah. So does any of this actually translate over into the work that you do every day? I hope it does.
Not so much anymore.
Yeah.
Well, like I said, I'm a privacy engineer, so I work in security and privacy. So most of my time is set in the screen. So having the opportunity to have be able to do something on the side that is, I guess, forward-facing is really awesome.
Nice. So if someone's actually just getting started with Android things and they've poked around a little bit and they have with maybe a Raspberry Pi or a microcontroller or I don't know, or they just have an idea, a dream and a prayer, right? Isn't that the phrase? How do they get started? What would you recommend? How they can build their own robots?
I would jump on the Android Things website and take a look at the code labs. So there are some code labs on there that are really good. They walk you through setting up the whole Android things. So if you get a kit, and I think there's a way to get a kit while you're here, actually.
Yeah, I think there's a scavenger hunt and also a giveaway, just FYI.
So if you have a kit, the code labs will walk you through the entire setup process. And by the end of them, I know there's one that uses TensorFlow to take pictures and identify dogs, and that one's really cool. But the important thing is that by the end of it, you've gone through the experience and basically done the hard part of learning how to get stuff on Android things and make it do things. And so once you jump over that hurdle, actually making changes and doing stuff and adjusting it for what you want gets really easy.
Yeah, and I would say you don't even really need Raspberry Pi or microcontroller experience. If you know a little Android, if you know a little Java, it's easy to get up and started. And the kits come with a rainbow hat, which has enough sensors to build something cool right out of the box.
Yeah, and you don't need hardware or embedded experience either. All the drivers for Android is hidden behind these clean APIs. So if you want to just control the motor, all you say is you set the direction and the speed, and that's it. So you're not rewriting all the device drivers from scratch to get the various components working.
Yeah, and I guess the biggest thing, or at least for me, is to not be afraid. I think a lot of people, when they look at programming opportunities, there can be a concern that, hey, I don't know what I'm doing. But the Android Things community is a great resource, and then also, just learning about it and taking part and getting hands-on is a great way to get started.
So it sounds like between the group of you guys, you're all super equipped, amazingly talented, which, no sarcasm, a completely honest statement. But everything went perfectly, and so that you didn't need any help building your giant trees or your giant robots, and you didn't run into any problems at all, right?
Yep.
No.
No. Not even close?
Yeah.
Or should we just talk about the stuff that went wrong?
Yeah.
So, yeah.
Yes.
Start with Rosie?
Yes.
So, like I said before, we were planning on building Rosie version 1 as a 3D from 3D printers using fabrication techniques to do so. Unfortunately, it was really big. I didn't realize that having something like 2-foot diameter waste and all this other components could cause such a concern. So about 2 weeks before, after exhausting every single option made available to us, we just said, hey, we're just gonna, just be scrappy and get stuff done. So that's where the, going around a million hardware stores came in.
So you're basically saying your project was too big for Google, right?
Maybe at the time, yes.
At least for Google's 3D printers
Yes.
at the time, right? I feel like that's an accomplishment. That's pretty impressive, right? To out moonshot the printers. Isn't that the goal?
Yeah.
10x them. So it's not bad. So then it sounds like you guys, when you went through it, to move forward, your next steps were to think about the same structure and redesign, and then think about how the materiality came into play with the software. Is that correct?
That's right. Okay. So we started out with something. So for example, we got PVC pipes for the arms. But later, when we put the motor on it, we found that was getting stuck, and the PVC pipes were just too heavy. So we had to come up with another solution, which is when Brittany found these perfect foam arms that we could use instead. And there are a lot of other things too. For example, when we put Rosie together, even on these bigger wheels, the weight was too much for the wheels to handle, because these wheels were designed for a fast race car. And so it couldn't take the weight off the trash can. So we had to cut pieces of plastic out so it can carry the weight. And a lot of things, even with the camera, we had to have enough lighting to get the exact expression, and we had to put it at the right angle. So every single step, we learned a lot, we iterated, and came up with some solution for everything.
Sounds like a lot of time taken to it. So obviously, I'm guessing you had a ton of time to build this, right? How long did it take for you guys to build Rosie?
Yeah.
So
it was, we had a month initially, but once the 3D printing option failed, it was about a week and a half, and I guess more accurately, more like 3 days of late nights and a few weekends trying to figure out what we were going to do and solving it.
That's not much time. And how about for Steve?
Steve, I think we put, so from the sensor side, I think we put most of that together in about 2 to 3 weeks. Ideally, we would have had more time. We would have, started immediately when you sent out the email. But, there was a lot of figuring out what we were actually going to do with Steve until Steve became Steve.
Yeah.
And you guys you felt like that was a sufficient amount of time, or you both needed a lot more time, or?
I think we would have needed 2 months at least, full time.
But you had 3 days.
Well, we had like 2 weeks to try and scramble, but the last 3 days were just insane. Like we were still, the truck was waiting for us. Rosie was still in parts. We were still working on it, and then like packing things that were done. And the head, I had to carry the head with me in the flight because the rest of it was already shipped. So I carried the head of the robot with me on the flight.
TSA must have been very fun.
It's crazy. Yeah. And so when you're building Steve the tree, a 20-foot tree, there's nothing went wrong there, right? So everything was perfect?
Everything was perfect.
Great.
Yeah.
That's good to know, so we can just keep moving on.
Not quite. So I designed the main tree, and while I was designing the main tree, I made a lot of assumptions about how the hardware and the software would work, and of course, most of them were wrong. Initially, I thought we were going to be able to control 4 strands of LEDs from each board, And then I got some of the strands of LEDs, and I got some of the boards, and I realized that this is not going to work. The way that the LED strands had implemented the standard meant that I couldn't do the things that I thought I could do. So I looked at, so the problem was that the boards only have one MISO pin to do the data writing to the strand. So I looked at using a technique called bit banging, where I picked apart the headers in the standard, and I wrote just the individual bits out through a GPIO pin to light up the strand and do the light show. But I got about 3 seconds per frame, whereas doing it the right way through the data pin, I got 30 to 60 frames per second. So I reached out to the Android Things community, and I'm like, this is what I'm trying to do, this is what I'm expecting to happen, and this is what's actually happening. And I hear back that there's a layer of abstraction between the GPIO pins and the software, for security reasons, of course. So it wasn't going to work the way that I wanted it to. And this is like a common thing with operating system-based dev boards.
It's called bit banging, right?
Bit banging was the technique that I used to write through the GPIO pins. So then, conveniently, we were able to get a bunch more boards, and the base of Steve the Tree, as you saw in previous photos, has 16 dev boards just kind of like sitting around the base. Each board is controlling one strand of LEDs, so it worked out in the end.
Yeah, and then another thing that we ran into, so I mentioned before that we were writing everything to the Firebase database so that we could make sure that we could modulate when we got to Grace Hopper to account for the different environment. Well, we didn't really account for the fact that we had 20 sensors writing about every second to the Firebase database, and we had 16 strips of LEDs reading from it. So it was a lot of in and out to the Firebase database.
So it was fine for a while until the night before the event, when the whole tree was set up and the sensors were ready to go, and we were just testing things. And then the DJ got there to test her setup. I think she was playing a Bruno Mars song with a lot of bass, and because the tree had microphones on it, it was reacting. It was like dancing along to the music. And then suddenly the whole tree stops working. So we scramble to figure out what's going on, like we check connections, and eventually I open the Firebase database logs, and I see that we're out of free quota. Like, and I'm just so happy.
You've all run into this problem at some point, correct?
I'm just so happy it happened the night before the event and not during the event. So Melissa and I start scrambling, trying to figure out how to fix our quota issues, like going through official channels, and eventually I reach out to someone I'd worked with on the Firebase team before, because my real project works with Firebase, and he was able to fix the quota problems, and we were up and running again.
Yeah, and so later that night, so the event took place at Epcot, and Epcot does this whole laser light fireworks show, and so later in the evening, the fireworks are going off, and Steve is going with the fireworks, and it was kind of like a nice sign that, okay, everything's going to be all right.
But does some of this mean that you guys didn't account for noise, or is it just because, does this also mean that you were just more successful than you anticipated?
Yeah, it was more about the scale of the project.
It's hard to design for something at that size, right?
Yes.
I think that's a good takeaway, that it's like when you're starting out, it's really hard to think about something at giant magnitude and stuff. And so, you know, you're able to kind of build and iterate.
Yeah.
So it sounds like between all of you guys, your software experience and background with Firebase actually helped with learning a little bit about Android things and troubleshooting some of the problems that you ran into. Is that an accurate statement? Do you think it made it a little bit easier to get going?
Yeah, definitely having Android experience helps, especially with an Android-based platform. And the Firebase stuff was great because usually when you're working with dev hardware, you have to figure out how the boards are going to communicate. Like, is it going to be Bluetooth? Is it going to be Zigbee? One of those things. But because this is Android and all of the Android libraries and ecosystems come along with this, we could just write to Firebase. We didn't have to worry about like the inner board communication.
Yeah, and the same when if you know any Android, it makes it a lot more comfortable because, at least in my case, I was learning Internet of Things mostly for the first time, and so Android was a very comfortable environment for me, so I could focus on the Internet of Things, and I wasn't learning 16 different things at once, just focusing on the one I needed to.
You guys?
And I had no experience with Android, so this was all new. Everything was from scratch, but having the hardware experience helped definitely.
Great.
Yeah, and for me, like I said, this isn't our software engineering isn't directly my day-to-day job, but you know, looking up the Android community and then having coworkers who have experience and has been really great and was this great experience.
So, what was something that you guys took away from this, or is there anything that you felt like you've learned from this? Hopefully, you learned something, maybe. Yeah. Any big takeaways?
So I learned that overnight shipping is really awesome. There were definitely a lot of things that I ran into working on the sensors. For example, realizing that I needed analog to digital converters the night before we had to leave, and doing some late night soldering. So getting those overnighted was awesome. So yeah, that.
Lifesaver, right?
Yeah.
I learned just to ask for things. When I started designing the tree, I looked for the open source drivers that were available and the kinds of LEDs that we could use, and I found these 5-meter strands of LEDs, and I'm like, okay, we're building a tree. We want to be able to get to the base of it, so the branches should probably start about 6 feet off the ground. So 5 meters minus 6 feet is about 10 feet. So then suddenly we have this 20-foot by 20-foot footprint. And I'm like, this is insane. But I kept going, just so I'd have the design doc and be like, look at this thing that we could have built that would have been awesome. And at the end, I put in a couple notes about how we could make it smaller or cut it in half, because I didn't think it would fit within our budget or in the event space. And then I sent it off to Melissa, and she's like, oh, no, this is fine. We can do this.
No big deal, right?
So for me, when I signed up for this project, I had no idea what was coming. I didn't even know we were going to build a robot. We had a lot of ideas we were throwing around, figuring out, and hey, robot sounded cool, so we signed up. But everything seemed doable to a certain extent until the 3D printing fell through. And at that point, we weren't sure whether we should give up or keep going and then just build it from scratch ourselves. So that was really, really scary. But we didn't give up. We just kept going and going, pushed it. And finally, we said, OK, let's get one portion working, and then let's move on to the other one. But in the end, everything came together. All the electrical circuits worked perfectly, and she looked beautiful, like a pretty android, and everything was great. So my takeaway is that have the confidence in yourself, believe in yourself, and keep trying. It will pay off.
Yeah, and for me, I know this is cliche, but don't be afraid of failure. Like Vaas was mentioning, we had a lot of iterations. We were first going to use a well-known licensed character from a large company, but then we evolved from that to Android, and then the 3D printing failing, and just a lot of things in between that didn't come out as the way that we initially thought. But ultimately, we used those failures as a way to learn and understand what was going on and improve, and we were able to get an awesome result after that.
I don't think they're failures. I think they're just like growing pains, right?
Maybe like constant iteration
Yeah.
periods to a successful model.
So then, from that, I can't let you guys go without asking, what's the next thing you're planning to build using Android things?
So when I'm not a software engineer or normally building Android things, I do a lot of dancing. And so I'm really, especially now that I know that the microphones worked really well with sound, I'm hoping to incorporate some Android things props into some of the dance performances that I do.
And I'm looking at how to add Android things to my bartending robot so that when someone walks up with a glass, it'll trigger the assistant integration and be like, hello, what are you drinking today?
Nice.
And I'm planning to build a Halloween project for my kids and the kids in the block. It'll probably be a candy dispenser, which has a bunch of pressure sensors and proximity sensors. So when kids walk up to it, it'll dispense candy for them.
Nice.
Yeah, and for me, I have recently learned how to use a sewing machine. I always knew how to hand knit, but I was always scared of the machine. So my goal is to hopefully integrate Android things into some of the textile work that I'm working on.
Great. And then with that, is there anything else you think that people should know before we bid this all adieu and move on? No?
Well, definitely do the scavenger hunt.
Yeah.
Yeah. So you can get yourself an Android things kit.
Cool.
And then hop on those code labs.
Yeah. All right. Thank you so much. And also, thank you so much for building the amazing projects you guys did and working with our team. And
oh, yeah. We do have, so just to mention real quick,
more.
We do have, we've got Hackster.io pages for both Steve and Rosie. So if you want more details, if you want to be able to see some of these pictures up close and personal and really, hopefully complement our work, not analyze it too much, you definitely take a look at those and check them out. It's also, if you have questions about it, it's a great way to post those questions, and hopefully we can answer them for you.
Great.
Yeah.
Sounds
And
good.
I want to thank Melissa.
Yeah.
Without Melissa's efforts and initiatives, none of us would even know each other. So
Yeah.
thank you.
Glad we
She's
have
always
this
there for us. She's always there to support us, and
Yeah.
we really, really appreciate everything that you have done for us.
Gave you stuff.
No, you did all the hard work, like
Yes,
providing
we
water
always
and
do.
food while we were, about to go crazy. Well,
Yeah.
No
crazy is not
worries.
the right word.
Well,
As we were trying to get work done.
Thank you, Melissa.
happy to help, and I'm so happy this was able to happen. So thank you guys all for attending. So happy you're here.